In this lesson, we will examine lines and angles, which are the building blocks of geometric figures. To begin, a line can be thought of as a straight path that extends without end in both directions. A finite portion of a line is called a line segment, so here AB is a line segment. Please note that we can use AB to denote a certain line segment, or we can use the same notation to denote the length of a certain line segment. Now this might sound confusing at first, but you will find that the intention of the notation is easily determined by the context. Okay, now let's talk about angles. Angles can be found at the intersections of two lines, and they are typically measured in degrees or radians. Now the GRE only requires you to know about degrees, so you don't need to worry about radians. Now this particular angle has a measurement of 55 degrees, which we can denote in several ways other than the one shown here. For example, we can use this notation to define an angle. Here, the letters A, then B, then C clearly define a particular angle. Using the same notation, we can also define this angle as CBA. Another common notation that you will see is as follows. So to show the angle's measurement here, we need only say that x is equal to 55. Now the measurement of any angle can be thought of in terms of its relationship to the angle found in a straight line. This angle is equal to 180 degrees. Now we can use this one piece of information to make various conclusions. For example, if we know that one of these two angles is 70 degrees, then we can find the other angle. Since we have a line here, we know that the underlying angle is 180 degrees. So it must be the case that x and 70 add to 180. If x plus 70 equals 180, then x must equal 110, so the second angle here is 110 degrees. To summarize this finding, we can say that the angles on a line must add to be 180 degrees. So for example, if we have these three angles on the same line, we know that the sum of those three angles must be 180 degrees. Now in geometry, 90-degree angles are of particular interest since they occur everywhere in life. These angles are so special that we have a special name for them. A 90-degree angle is called a right angle, and we will often denote right angles as follows. Now please note that if this notation is not present, then we cannot make any conclusions about the angle. Although the angle certainly appears to be 90 degrees, we cannot assume that it is 90 degrees unless we are specifically told so. Now if two lines or line segments intersect at a 90-degree angle, we say that they are perpendicular to one another. Okay, here's another definition. To bisect is to cut or divide something into two equal pieces. For example, let's say we take an angle and draw a line that splits the angle into two angles. If those two angles are equal, which we can denote as follows, then we can say that line L bisects angle ABC. Or we can say that line L is the bisector of angle ABC. We can also use the word bisect in a different way. If a line divides a line segment into two equal lengths, then that line bisects the line segment. Finally, if a line divides a line segment into two equal pieces, and that line is perpendicular to the line segment, then that line is called a perpendicular bisector. Okay, now that we have covered several key terms in geometry, let's examine an important property of intersecting lines. Notice that the intersection of two lines creates four angles. These two angles on opposite sides of the intersection go by several different names. These names include vertical angles, opposite angles, and vertically opposite angles. For this module, I will use the term opposite angles. Also note that in this example, angles B and D are opposite angles as well. Now the important property here is that opposite angles are always equal. So if we have any two intersecting lines, these two angles must be equal, and these two angles must be equal. Also note that since angles on a line always add to 180 degrees, we can also say that x plus y must add to 180. Okay, now let's take the properties we have learned so far and use them to find the measurements of angles W, X, and Y. Let's begin with angle x. Notice that these two angles are opposite. Since opposite angles must be equal, we know that x must equal 50. Now let's find the value of w. Here, these two angles are angles on a line. Since two angles on a line must add to 180 degrees, we can conclude that w plus 50 must equal 180. From here, we can subtract 50 from both sides to see that w must equal 130. Finally, to find angle y, we can apply either of our two rules to see that y must equal 130. Our last topic in this lesson is parallel lines. Two lines are considered parallel if they do not intersect, and we will typically use this notation to indicate that line 1 and line 2 are parallel. Now, if you are told that two lines are parallel, you might want to add some arrows to your diagram to remind you of this. Now, parallel lines on their own are not that interesting. Things get interesting when a line intersects our parallel lines. When this happens, we call that line a transversal. Notice that the transversal creates several angles, and it turns out that many of these angles are equal. For example, all of these angles are equal. So if you know the measurement of one of these angles, then you will know the measurement of all of them. Similarly, each of these angles are equal, so we essentially have 8 angles where each angle is either x or y. Now, parallel lines and transversals are frequently tested on the GRE, so make sure that you can identify all of the equal angles when a transversal intersects parallel lines. Now, as an aside here, it's important to know that since angles on a line always add to be 180 degrees, we can also say here that x plus y must add to be 180. Okay, to summarize. In this lesson, we learned that angles on a line add to 180 degrees. Opposite angles at an intersection are equal, and we learned some important properties of parallel lines. As we progress through this module, you will learn many more properties and rules to add to these ones.